This is a reciprocal function. The equation is 1 over x. And I want to point out some things. So this is the equation right here, 1 over x. And notice it has the point 1, 1, good. It has this point right here. What's the x value for this point? 0.5. Yes, 0.5. I'm going to put 1/2. And what's the y value? It's reciprocal, right? 2, if you flip it, it's 1/2. 1/2, if you flip it, it's 2. These are called reciprocal functions. Right here, this is the point 2, 1. Or I'm sorry, 2 and what? 0.5. What is this right here? 1/2. You see how it's flipped? Reciprocal. Same thing on this side. -2 is right here at -1/2. It's just flipped. This is the point -1, 1. This is the point -1/2 paired with a -2. They're just flipped. And you'll see this throughout. This is 4. What do you think the y value is? 1/4. Okay, so it's just a reciprocal function. Okay, so if I were to make a table, and I'll make a table shortly, you'll see how it's just flips of each other, reciprocals. So if I were to change, this is the parent function, 1 over x. If I were to put maybe like a +2 down here, what do you think would happen to my graph? Exactly, it would go to the left too. So let me exit out of here. Okay, you see this is the x + 2, and it shifted to the left. So all of those points, it just moved to the left. You guys see that? Okay, so the transformations are still going to be the same. So let's see how it will happen. What will change if I put a negative in the front? What do you think will happen? Yep, it'll reflect across the x-axis. So see how it hops across the x-axis? Okay, so if I put a negative in front, it'll reflect and it'll look like that. Also, if I put a plus, if I put +10, what will happen? Up to whatever I put. So if I put +10, it went up to 10. So let me scoot up. It went up to 10. You guys see that? All right, so let's go ahead and take some notes. So the type of graph, the shape that we call this is a hyperbola. That's the shape that it makes when two things are just opposites. Like that. Those are hyperbolas. Okay, so I'm going to graph the parent function. Remember at 1, it was at 1. What was it at 1/2? 2. You just flip it. What was it at 2? 1/2. At -2 is a -1/2. -1, -1. And -1/2 was at -2. Those are your points. I'll make a table for you just so you can visualize it. -2, flip it, it's -1/2. -1, you flip it, it's still -1. -1/2, flip it, it's -2. 0, we're going to put undefined. 1/2, flip it, you get 2. 1 with 1, 2, flip it, you get 1/2. Those are the points on my table. This one is undefined because there's an asymptote there. So you guys have an asymptote right here, which you need a sketch. Go ahead and sketch your asymptote. And you have an asymptote here. If you wanted to continue making more points, 3 would be 1/3. So right there. 4 would be 1/4. So you're just getting closer and closer to the asymptote. Y'all see that? At 5, you'd be at 1/5. It just gets tinier and tinier this way. All right, so guys, that is your parent function for the reciprocal graph. Okay, so let's talk about the domain. Domain is always starting on the left, so this will go forever this way. So I'm going to write -infinity. And then I'm going to follow my graph, and it goes very close to the asymptote. Doesn't touch it, but it goes up to the asymptote at 0. And then it continues on this graph. Starts at the asymptote at 0 and it goes to the right. So that would be 0 to infinity. So that is how you write the domain in interval form. You can also say x cannot be 0 because there's an asymptote there. Those are the two ways you can write it. Range, you start at the bottom down here. That's pointing down to negative infinity. If you follow the graph, it goes up towards this asymptote, which is at 0. Now continue on to the second part. It's starting down here at 0, and it goes up to infinity. Or you could just say, y can't be 0, because there's an asymptote right here. Okay, your vertical asymptote. Let me highlight the vertical asymptote. This is the vertical asymptote. This is the line that your graph will never touch. That crossed the x-axis at 0. So I'm going to put x equals 0. Your horizontal asymptote is right here. That crosses the y-axis at 0. So this is the basic graph. It has not been translated left, right, up, or down. It hasn't been reflected. It wasn't stretched or compressed or anything. This is just the basic graph. Let's look at some transformation graphs. Before we do that, let's take some notes. What do you think goes in the first blank? What does this do? Yes, horizontal shift. So if you have a plus sign right here, that means which way does it go? Left. And if you have a minus sign in there, it will go to the right. Okay, we talked about h. And in parentheses, your h value, or draw an arrow to the h, that tells you your vertical asymptote. Your k value is what kind of shift? Vertical. That tells you if it goes up or down. So if you have a plus, it goes up, and if you have a minus, it goes down. This will also tell you your horizontal asymptote. What happens if A is negative? Yep. You are right, Aiden. It's reflected across the x-axis. Now, if the absolute value of A is greater than 1, this is a vertical stretch. And if it's between 0 and 1, it's a compress. So your equation for a vertical asymptote will always be x equals. For horizontal, it will always be y equals. Okay, so let's say I give you the function. What is the transformation here? Yep, it went down 2. Now, let me give you some notes real quick before we begin. I'm going to highlight A and K. That affects Y values. Okay? All of the transformations affect the Y values. All of these affect Y. Okay? The only thing that affects the X's are what's right by the X, left and right. This is the only thing that affects X. Okay? Everything else will affect Y. Okay, so let's go back here. I'm going to remind you of the parent table. So if I have -2, flip it, -1, -1/2, flip it. 0 is undefined because you have asymptotes there. 1/2, flip it. 1 goes with 1, 2, flip it. This is a reciprocal parent table. Okay, now the transformation that happened here is that it went down 2. That affects the Y values only. So on the y side, I'm going to subtract 2 from every value. You don't have to do the undefined. You just need to subtract 2 from every value. So my new table, the x's stayed the same. Nothing happened here. The only time your x's will be affected is if something happens right here, if it moves left or right. It didn't move left or right, so the x's will stay the same. Okay. Negative 1/2 minus 2 is negative 2.5. Negative 1 minus 2, that's negative 3. Negative 2 minus 2, that's negative 4. 2 minus 2, 0. 1 minus 2, negative 1. 1/2 minus 2, negative 1.5. These are your new values. So I'm going to plot these points. Negative 2, negative 2.5 is here. I did that one. Negative 1, negative 3 is right here. Did that one. Negative 1/2, negative 4, right here. 1/2, 0 is right here. 1, negative 1 is here. And 2, and then negative 1.5 right there. So those are my points. And let me go ahead and graph my asymptote. Did I move left or right? No. So I'm just going to write my asymptote at 0. It didn't move left or right. It still goes through the origin like the parent does. It goes through the origin. This went down too. So that's my other asymptote. So those are my asymptotes. Now you can go ahead and draw your graph. Go close to the asymptote, just don't cross it. Don't touch it. You can get very close. So this is your graph. Okay, your domain. X cannot be 0 because that's where you have an asymptote at the x value 0. Your range, y cannot be negative 2 because that's where you have your asymptote. So these need to match. Your vertical asymptote is at 0, and your horizontal asymptote is at negative 2. So your domain and range should have not equal to, and then your vertical asymptote and horizontal asymptote should have equals. Okay. So my original table, I know negative 2, I'm going to flip it. Negative 1 is just with negative 1. Negative 1/2, flip it, it'll be negative 2. 0 is just undefined. You can skip that. 1/2, flip it, it's 2. 1, 1, 2, flip it, it's 1/2. So this is my original table. Now, remember, all of these affect the y value. So vertical stretch, reflection, this is multiplication. So guys, go ahead, put this in parentheses. I'm going to multiply all of these by your a value. Your a value goes here. What's my a value here? Negative 1. So this will be negative 1. We're multiplying all of these by your a value. Next, it went up 3. So I'm going to add 3. So those all affect my y values. This is the y side of the graph, of the table. The only thing that will affect my x values is this right here. And what happens here? It went to the right 5. If it's right, I'm going to add 5 to this side of the table. These are the x values. Okay. Now, guys, I'm going to go ahead and draw my asymptotes. I know it went right 5 and it went up 3. So right 5, 1, 2, 3, 4, 5. That's this asymptote. So I know my vertical asymptote. and it went up 3. That's right here. So these are my asymptotes. This is my horizontal asymptote. This is my vertical asymptote. The vertical asymptote is at x equals 5, and your horizontal asymptote is at y equals 3. Okay, let's figure out my new values so I can plot them. -2 plus 5 is 3. -1 times -1/2. That's a positive half. So 0.5 plus 3 is 3.5. Next, -1 plus 5 is 4. -1 times -1 is a positive 1. Plus 3 is 4. Next, -1/2 plus 5 is 4.5. -1 times -2 is a positive 2. Plus 3 is 5. All right, halfway there. 1/2 plus 5, that's just 5.5. -1 times 2 is -2. Plus 3, that's 1. This is 6. This is -1 plus 3, that's 2. This is 7. And this is 3.5. Okay, so I'm going to plot those points. Wait, did I do that right? No, -1 times 1/2. -1 times 1/2. This will be 2.5. There we go. All right. There should be no values repeating. If any numbers repeat, then you know you did it wrong. All right, so 3 and 3.5. So that is 3, 3.5. That's right here. So I did that one. 4, 4. That's right here. And 4.55 right here. So I can go ahead and graph this side. Next, 5.51. That's right here. 6, 2. Right here. And 7, 2.5 here. So that's my graph. And of course, your domain, well, you cannot equal the asymptote, so it can't be 5. And your range, it cannot equal the asymptote, so it cannot be 3. Good question. So for example, let's say I had 2x plus 3 minus 7. You know, this went left 3 and down 7. So you want to do left 3 and then down 7. 1, 2, 3, 4, 5, 6, 7. So you know your graph will look something like this, right? Yeah. That's a rough sketch. I want exact points. So you need to do the table.
Don't we know that it's just the 1 and then 0.5 on both sides of it? So if we can just figure that out in our head, do we need to write?
So I know normally it would be right here
But then you
and here, but then you're going to times it by 2, so it should be right here. So get those exact points.
Okay.